This is Calculus with Allenson, and we're doing problem number 5 from the 2005 BC test. First part says that this car is traveling on a straight road, and this is a velocity function from 0 to 24 seconds. Car's velocity is measured in meters per second, and here's a graph for it. So A says find the integral from 0 to 24 vt dt. Using correct units, explain the meaning of this. So when you integrate a velocity function, you're going to get distance. And we're trying to find the area under the curve right here from 0 to 24. And so basically we have a trapezoid with a base 24 and another base of 12 and a height of 20. So we're going to have 1/2 base 1 plus base 2 times the height. And so when we multiply that out, we should get 360 meters. The car travels 360 meters in 24 seconds. B says v prime of 4 and v prime of 20 that find the value or explain why they do not exist. So v prime of 4 is a little bit trickier because it doesn't exist here. There's no, the slope on the left hand side is 5 and the slope on the right hand side is 0. That's the essential reason. And v prime of 20 actually does exist. It's right in here somewhere, and that slope is negative 5/2 meters per second squared. This one doesn't exist. Okay, so one way that you can show that is the limit as t goes to 4 from the left hand side. So the time is approaching 4 from the left hand side. What we're getting is 5, the limit of the derivative. So you could write it all out, but and then the limit as t goes to 4 from the right hand side of the derivative is 0, and these are not equal. So that's why this does not exist. C. If a of t is the car's acceleration, then write a piecewise defined function for a of t. Well, we know it has different accelerations in each of these three parts. So acceleration is derivative of velocity, so the derivative is the slope of the velocity. Slope here is 5, slope here is 0, slope here is negative 5/2. It's 5 from 0 is less than t is less than 4. It's 0 from 4 is less than t is less than 16, and it's negative 5/2 from 16 is less than t is less than 24. And t is, when t is equal to 4 and when t is equal to 16, a of t does not exist. D, find the average rate of change of v over the interval from 8 to 20. So that would be just v of 20 minus v of 8 over 20 minus 8, which is negative 5/6 meters per second squared. And the mean value theorem does not apply because it's not differentiable on the interval. Right here there's a problem. So mean value does not apply. V of t is not differentiable at t equals 16. Okay, as far as the points on this problem, 2 points for A, 1 for the value, and 1 for the meaning of the units. B, 1 point of saying v prime of 4 does not exist with an explanation. 1 point for v prime of 20 equals -5/2, and 1 point for getting the correct units. C, so we're 2 points, 1 for finding the values 5, 0, and -5/2, and 1 point for identifying the constants with correct intervals. So having the correct intervals. D is 1 point for the average rate of change being this, and 1 point for an answer with an explanation.